Welcome again to Wickerson Studios. I'm continuing with this series of processing some simple scripts. This one I'm actually looking into nesting some loops and seeing what I can do with that with the Rhino geometry as RG and the import maths as usual. And I'm actually pretty happy with the shape that I created here. I'll take my turntable out because it's just kind of slow. I've got it in top view. It's kind of a cool thing. Um, off the top, and then this image here is really a nice single brep. So if I go over here and show what happened, sometimes I like to start from the finished. And keep in mind, I use the kind of red, yellow, green to show you what I'm excited about. Red is where the Python script is, yellow is the parameters, and green is really the outcome. So what I have is a very simple, beautiful closed brep, and you can see the lines that are used to generate that in the ray trace. So as we step back in that script, you'll see I put it through a variable pipe. I used a range and a sine function to get what I like, and I capped it with a 2, so it becomes curved ends. Those are generated by, if I jump onto here, and you can kind of see it more in this window, I guess I could change the view. I've never done this, so let's do it. Let's set the view to another perspective over here, and hopefully that would work. Set view to perspective. And of course it didn't work. Oh, I have to exit what command I was in. So try that again. Sorry for slowing down, but you might learn something from my errors, which is probably better. And there we go. We've got a nice little technical view of that. I'll put it into artistic. And you can see actually probably shaded's the best. Ghosted can be nice too for appreciating what's happening, but as a single brep form, I could make that in Rhino, but in Grasshopper I could as well. But I'm really going to use my script and my maths, my a cos h and a sin h, to make this through a nested loop, and you end up with a pretty nice geometry that I think I would like to take that into glass or take that into aluminum or zinc or bronze. Excited about it as a form, but let's just take a look at it as we go through. The lines being generated are basically, if I take this off, actually if I take my render and I take it to disappear, you'll see I actually have some very cool lines that have been generated from two geometries, raising and lowering it in a jittered pattern off of, I believe, not even a mirror, just one going up and one going down in a negative direction through two ranges. And they're stem from points, these points. So I've got to get to a script that actually can pull those points out, and here it is. It's got an attribute XYZ, and it's got an attribute UVW, not to confuse with local and geometric point system, cardinal points, but or points on surface or points on the construction plane. But I also have an amplification factor, and I funnel that in some interesting ways. And actually, I think this is a factor of 0 to 1, which is controlling the jitter function of what comes out. Now, that's all secondary, even though this actually controls, this is actually tied to the Python nodes. So we need to look into that. The script here is pretty dead simple. It is a import Rhino geometry as RG and import maths, create a list, and throw through an I range, your XYZ, start, stop, step, and then your J, start, stop, step, and then RG, use your Rhino Common Language as point 3D instead of 3D point. I think that's what it's called in Rhino script syntax. And then I simply put it into I, J, and what was 0, but I decided to take those, put it into an amp factor, and what happens is those geometries can be controlled by not only where the X is as I slide through the, oh, I shouldn't even try and do it because I have it on a pretty big extrusion. Let's go back and take this one and just, I'm going to disable that, and this one I'm actually going to put on preview so you can see what's happening before the union, because it's actually a fairly fast moving strip at 14 milliseconds there. So yeah, you don't want to be wasting your time to see different iterations, but as I go into here and grab those points, they're one thing to watch as I control in the start. It won't work at a z factor. That's just because of sine and cosine and something there. And then the step factor can change, and you get different steps between there. You have to deal with kind of integers on those values. But you can see that this can get another start, step, stop. Start it off at a low number, maybe not 0. And I probably should go in here and just edit that so it doesn't go down to 0. And I might do the same with here, even though cos and sine are a little different. If you know what I'm talking about mathematically. We're going to take it through an iteration of 10. I wanted those to be different, and then I can bring up my steps to have these steps, and now I've controlled some pretty cool points, and of course I can loft those up and down with the amplification. I shouldn't say loft, lift them up and down, And then we're left with a wonderful geometry that there it is, informed by a variable pipe. And all these beautiful, simple lines right here in the ray traced can actually be baked and put in, but I would never generate rotation geometries and beautiful curves like this. And if you know anything about Rhino, it's not about, it really is about curve and surface manipulation, constructing curves from points. And once you get into that, you can get into the surface manipulations by understanding that. So I'm going to go back out. Very simple script to play with a little bit of maths. And what I'm trying to do, and you've seen me do this before, I'm trying to go through the maths and gain a visual understanding of all of these wonderful tools that are within that library and how I can activate geometries because of them. I am not in the Rhino window in my mind. I am not stressed out in the Grasshopper window in my mind. I have enough proficiency there that I'm playing with it. I'm going to take this over to preview off, and this one I'm actually going to enable. It's going to take 3 or 4 seconds to load up and show what's there. But I'm not in the Python window so much because the scripts are being handed to me. What I am doing is dipping into the math library and trying to go back to some mathematical roots. And this is taking a little bit of time to load because I put on a lot more steps, smaller steps, larger stops, and earlier starts. And you might remember that's what I was doing in the Python node. So now it's just taking time to say what it wants to do. And it doesn't help that I'm in a technical view. Maybe I am, but certainly doesn't help that I'm in a ray trace view here. It's going to slow it down. So a little bit of patience on this. It's 6 minutes and 30 seconds. The scripts are so general that I don't think it's about copying a GH file. I don't think it's about really, you should slowly internalize the basis of these scripts. And I was putting them in here, but they just seem too dry and too introductory that where, I just have to pop it on like this. That's 51-second script to make that Boolean union because there's so many that brep union in there. And whenever I throw it into this green variable pipe, it's almost like it's the color of the words, and I'm never able to see my bifocals tool. And there is a conflict here. Probably, empty brep parameter. I produced too much jazz and information in here that I'm going to have to go back in. And what I'm going to do is just not even attempt to do what I just did. Enable. I just kind of crashed out the script. It was just too much for it. So as that's deciding to go on disable, a little bit of a slowdown here, but you can see the limitations of this. And the more complex and exquisite or perfect you make these lines or forms, the tougher it does have time building geometries. You still have to take these out of Rhino and send them somewhere. So when you're exporting them, you're turning these NURBS surfaces into meshes and NURBS based objects into meshes to do that. And of course, to physically render or make things, that's going to become essential. Yeah, there's a slowdown here, about 51 seconds. So not the best tutorial I put online, but it gives you a sense of the troubleshooting you do have to go through on this. It doesn't have that I should take the time to take this out of ray traced, even though I'm not sure if that's really slowing it down at all. Yeah, there's our lines and curves, and I just wanted to get that object disabled and get this one on a preview on, and then I'm able to really move fast. But that's the system. It's really getting an understanding of going in and being able to generate these shapes from those curves. Fantastic curves, actually, if you ask me. And stemming from just a sense of jostling and jumping those points up and down. And because I said these points were really going under a small step count, if I took the step count up a bit and it skipped a few, that's going to make for a much faster geometry as I go into it. And still, that's ready to do a Boolean. Is it a Boolean that I have there? I think it's a solid union. Yeah, that's what I'm doing, solid union. So I think this one I could put back on enable and move pretty fast. Yeah, 402 milliseconds. But you can see how that really just becomes difficult and slows down. Sorry for the staggering little video there. I'm not going to redo it. The main gist of it is get your stuff going, get your Python node, get into the nested loops functions with the Rhino geometry. You're still only really importing point 3D. And even though I'm not going too hard into the namespaces within Rhino geometry, I am going deeper and deeper into those maths to try and create some interesting things. And the script won't work, of course, with that little math dot there. Actually, it's strange that it did pass by math dot with nothing after it. Didn't know that worked. Thanks for watching. Like I said, I'll stumble a little bit through these, but hopefully you keep in mind that they're pretty creative and spontaneous in what I'm doing. Thanks for watching.